So with the OSI 400 board running, its power requirements are +5 and -9. That -9 is used by the 1702. I've been using a bench power supply on my Rigol DP832 to generate that +5 and -9. However, it's really too big to move around and use, and so I need a power supply that I can actually use with the system. So this is a Mean Well RT-65B. It's normally +5 at 5 amps, +12 at 2.8 amps, and -12 at half an amp. That -12 is accomplished by a 7912 voltage regulator here. So it's just a 3-pin voltage regulator for -12. And I'm going to substitute a 7909 in there and see if I can get this supply to provide -9 instead. So there's going to be a little bit of trickery involved here. The regulator that's in there is a completely isolated regulator. The replacement I have is not. Is this guy here. So I'm going to have to use an insulation, like a mica pad or something, and then I'm going to have to use a shoulder washer and hope I can get the hardware in place. Not that it's going to dissipate a lot of heat, it's not. So really I need to get that regulator out of here. And I've got the top off, I've got the hardware out, but you still can't get the PCB out. And the secret there is there was 2 screws underneath the cover here, and of course this voids the warranty as soon as I do it. But we'll take the first screw out. Feel around for the second one. It's right here. I've repaired one of these in the past, and there it is. The board just falls right out. I've got the desoldering station warmed up. I can see the pins we want to go after are right there. So let's see if we can release the device. That really, yeah, I can feel it. It's loose. It's flopping around. So there was a little bit of thermal grease on that, not much. So really now the question becomes getting this guy in, and in correctly. So let's go ahead and look at the... So I've got a whole bunch of voltage regulators, and this is the container that has really the mica washers, this kind of stuff. I could use a sill pad. It's not like this is going to dissipate a lot of heat. There's not a lot of current draw. And a shoulder washer, one of these nylon ones, should work. And we'll pull one of those out. So the question becomes, does the existing mounting hardware, which is this screw here, fit through the shoulder washer? God, that's hard to say. And yes, it does. So this is going to work. So really, I'm going to use the heatsink compound to kind of hold that in place. Hopefully. That'll produce insulation and thermal transfer. I guess we'll put the voltage regulator in next. It should just drop in. Assuming I can get the pins lined up with the holes in the PCB, which is proving to be a bigger challenge than I would have thought. It's going to sit there. Get why is that so hard to say? The shoulder washer. So the shoulder washer is a nylon washer. It goes down into the tab, so it sits on top of the tab, and then it's got a shoulder that drops down inside of the tab to completely isolate this screw from the heatsink behind it. So we've insulated it via the sill pad. We've now insulated the screw. Itself, so we should be able to now tighten that back down, assuming I can find the screwdriver here. And there it's caught. And I'm going to get a little bit of tension on it. And then before I go any further with this, I'm going to take my meter, and I'm just going to make sure there isn't a short. So I should be able to go to the tab. If I touch the screw makes contact through, but the tab itself doesn't. So if I'm on the screw and the tab, I don't have continuity. So the nylon shoulder washer is doing its thing. I should have continuity there. I should not to there. So it is isolated as it needs to be. So let's go ahead now and torque that up a little bit better. Doesn't need to be super tight. Let's solder these pins in. And then we'll power this guy up and test him. Got the wrong glasses on for this. See any shorts between those, but I don't have the best glasses on for this. Yeah, I don't see. Nope, it all continuity wise makes sense. So that swaps that -12 for -9. I'm going to sit this back down into the base. Actually, I need to clean up a little bit this panel first, so that the screws will go back in. So I'm just going to cut away the old sticker here, because it's no longer valid and it's no longer got any kind of warranty. Not that I don't have a receipt for it, so I don't know, would I have done a warranty return on it? No. They're good little power supplies, these Mean Well. They're almost ubiquitous. I order them on Amazon just because it's easiest, although I bought a couple on DigiKey as part of a larger order. That sits back down in there. Why can't I get that to line up the way it needs to? We should have a couple of, there's multiple screws that hold this all together. There's these here on the side. I'll get these started in. There's one of them. There's one here. There's two here on the back that we'll go ahead and put in. Just got heatsink compound on me. Of course I do. I didn't check this supply. Oh, I know it was working. This is the one that I tried to get the PMC 100 running on, and couldn't get it to go, and I ordered a replacement, and that didn't go either. And it turned out to be the system clock wouldn't start due to the RF noise the power supply was producing, and adding a little bit of delay on the startup of that fixed it. We did that in a different video. So let's go ahead and get the chassis ground to the board hooked up here, which is this screw right here. And I am not going to go any further with the reassembly at this point. Let me get a line cord to test this with. So there is a temporary line cord. I guess I can sit this back in place. We'll go ahead and do that just so it's safer. The screwdriver. Need to pull the screw back out to put the cover here on. Cover then slides forward. The cover's got the markings on it for the terminals, which makes it a lot easier to do if you can see the markings. So this screw here gets all the grounds, common PC board and the outside of the case. There's a little tab. If if I can get it to hook in there, that holds the back together, and that is back together. So we have earth right here, which is the green wire in the line cord. We have white, which is the neutral. Again, this is US wiring and color coding. It's different in other countries. Black, which is line. I hope I've got that right. It doesn't matter. If I got that backwards, We'll get the meter over here. We'll get it set in place. We'll get it to volts. And I'm hoping that that minus 12 isn't used as part of the internal regulation. Because if it is, this isn't going to work. So I need to pull existing line cord out. Hopefully when I plug this one in, we won't get smoke and fire out of the power supply. I guess I'll find out, won't I? Oh, here. LED is on, so we do have power. Let's get to common here. Plus 5 is here. And this should be plus 12. And this should be minus 9. Minus 8.9. Perfect. That's exactly what we expected to see. We've swapped out the minus 12 for minus 9. So I've got the minus 9 I need, and the plus 5 to power the OSI 400 main board. So the CPU board. So that's perfect. That's exactly what we wanted to see. So I'm happy with this. So nice little tweak. So let me unplug it. And I think that will wrap this video up. I don't have a whole lot else to add here. I guess I hope to see you in a future video.